Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithms series. In this series, we will be implementing algorithms and data structures using Scala functional programming approach. This video is part 2 to Dijkstra's shortest path algorithm. In part 1, we have learned what is Dijkstra's shortest path algorithm, how it will traverse, how it will create the shortest path. In this part, we will be implementing weighted graph, which will be leveraged to implement the shortest path. Just for an overview, weighted graph would look something like this. If A is the node, then B is a neighbor where to add B to A, we have a weight 4. Similar it was the C, the weight is 3. So let's create the weighted graph. First, we have to create the edge. First we need to create weighted edge. So it will be of type V. Weighted edge is something that we will be using in our adjacency list. Now we will be implementing graph. So similar kind of graph we had implemented for our topological sort BFS and TFS. You can take a look if you like. So first method is our vertices. It is going to be sequence of V. So what is a vertices? So vertices are just the node of the graph. Second method is edges. Edges are going to be sequence of a tuple v comma v. So an edge is a tuple of two vertices. Vertices. Then we need to always add edges. So it's going to have first parameter as v and second parameter is weighted edge of type v, which will indeed return a graph of type v. Fourth method would be neighbors, and here how it is going to be. So neighbor of what? Neighbor of a vertex which is of type v. It is going to return a sequence of weighted edge because all the neighbors are a weighted edge. Let's implement a weighted graph. So it's a weighted graph of type V. Again, we need to have adjacency list, same as what we did for any other directed graph for topological sorting or BFS or DFS traversal. So first is the value, second is the sequence of weighted edge. Earlier we just had a sequence of edge, but now this is going to be weighted edge extends graph of type V, and we implement the methods, 4 methods that we have. So let's implement these methods. So first method is your vertices. It's going to be adjacency list dot keys dot to list. So this is basically we are collecting all the key values as the list that will give us all the vertices that we have. Then we are trying to get the edges, all the edges except the weights. So adjacency list, we get it from adjacency list. This is how we are going to store our graph, and then we have this case where it is going to be v comma edge list, and edge list will hold all the values. So edge list dot map, and it's going to be e, and it is going to be v to e dot destination. Okay, so here till here we got our edges. Now when we are going to add an edge, first we need to create a neighbor where a neighbor to a So if already there exists a neighbor, then it is perfectly fine. Otherwise, adjacency list dot get, or else if there is nothing, it is a new or fresh node. I mean, it's just the beginning. So if we are adding B to A, then in that case we just have just A with no value as weight, so it will be appending it to adjacency list. So it will create a new weighted graph where the first value would be adjacency list, then we will be adding it, and what we are going to add, A and A's neighbor. Then we will go to the override neighbors. Here it is again going to be simple and straightforward. Adjacency list dot get, or else if nothing is found, then it is going to be vertex comma nil. So it is going to traverse, and at the end it is going to return vertex comma nil. So explanation to all of these will be similar to what we have seen for DFS and BFS. So here it's self-explanatory how we are adding the edges. One part is left here is we need to create this directed graph using this apply method. So apply will be the adjacency list of type map, which will be v comma sequence of weighted edge of type v, which will return a graph of type v. It will be new weighted graph of adjacency list. Next, if I want to create an empty weighted graph, so it is going to return a graph of type v, which will be new weighted graph, and here we are going to pass this value, and yeah, pass it as a value. So eventually we have implemented our weighted graph, and now we will leverage this structure to implement the shortest path algorithm. So guys, if you enjoyed this video, please like and subscribe, and code to this video will be available in the description as a link to my GitHub repository, and do not forget to press on bell icon to catch up on my future updates. Thank you.